So it's pretty simple, just like, you can just go like that later if I actually get to another board. But I'll try to focus on this board for a while. All right?
I can move it if you want.
Yeah. Yeah. So generally, if you're the camera person in here, there's no reason to. It's not important where I am, and you know what I look like. What matters is what I write on the board, generally speaking. So like, a number of you will end up working the camera as we go on, right? Because you'll sit in different places and stuff. So, you know, as a general, just think about what you'd want to see if you were a student watching the video later, right? Let me put this away here. All right, so go away. Don't worry. All right, so this is Math 121, Section 2, right? And this is college algebra, right? I'm James Cook. I worked here before for about a decade, and I took a 3-year sabbatical, but now I'm back. I'm not exactly new here, but I am new here. It's like my first semester using Canvas residentially, so I'm getting used to it too. I should tell you my office hours are, I'll have to go look, I don't have them memorized. Let's see here. Where is my office? That's a good question. 4382M. Do you guys know where that is?
In here?
In here. Well, it's not literally in this room. Although, interestingly, where I worked before, my office was actually sort of in a classroom. So I would literally tell students, my office is back there in the back of the class. But here, no. It's way down the hall. At the very end, there's this interdisciplinary suite, I think. I'm M, all right? And my office hours are scheduled 12:50 to 2:10, Monday, Wednesday, Friday, and 11 to 2, Tuesday, Thursday. All right? So, any questions about that? I also try to answer email, obviously. You guys know my email? It's jcook4. All right. All right. So there are a few things you need to do to succeed in this class, right? Number one, come to class, pay attention, right? We will do some in-class exercises. And those will earn you some points, right? Coming to class actually earns you points. I have made 60 points of your, so you know how we work here, it's a 1,000-point scale, right? So like 900 to 1,000 is an A, that's what you want to make, right? 800 to 900, well, 800 to 899 is a B. 700 to 799 is a C, and we don't want to talk about the rest, right? So, so that's the grading scale here. Now, so I have 60 points of your grades for participation, right? How do you earn participation? Well, you come to class. You do the exercises we do in class. There will be, so 60 points for participation. There are 90 points for quizzes. Now, quizzes, maybe you've had a class before where you have a professor give pop quizzes. That is not how I roll. There are 3 quizzes in here, all right, 3. And each one is worth 30 points. All right, if you look at the course plan that I just had you give you a copy of, it will tell you when quiz 1 is. Can somebody tell me when it is?
September 14th.
September 14th, which is sooner than you think, right? Okay, so September 14th is quiz 1. When is test 1? September what? 21st? Yeah. So how much are tests worth in here? 450 points. How many tests are there? There are 3 tests. Each test is worth 150 points. So the way this works, my intention with the quiz is essentially a pretest, right? So the quiz will take most of the class period, right? You'll have time pressure, closed book, all right? Closed notes. However, I do offer you this. You're allowed 1 page of notes front and back for the quiz, all right? And you're also allowed 1 page of notes front and back for the test. I would urge you, as you're working on your homework, make this study sheet for yourself, right? So that when you get to the quiz, you're not like, oh, what should I put on the sheet, right? You already have the sheet ready, right? Start making that sheet today. I'm going to write some things on the board that I would urge you to put on the sheet, because if you know them, great, but if you don't, it's nice to be able to look at them on the sheet and remind yourself how they work, okay? But otherwise, the test is timed, the quiz is timed, all right? I have some students who are like, what, there's a time limit? Yes, there are time limits on tests and quizzes, all right? Now let's see here. So, of course, if you have if the Office of Disabilities and so forth, the ODAS people have given you an accommodation, that's another matter, but, the default here is that it's timed, all right? Now, what else was I going to tell you about? Oh, then there's that thing called a final exam, right? Which is worth how much? 200 points, all right. The final, there's just one of them. That's good, right? And let's see, what's that add up to? 750, 810, wait a minute, I can't do math, 650, 710, that's 800 points, right? What's missing? Homework, yes. How much is homework worth? 200 points. Now, remember I just told you I'm getting used to using Canvas residentially. There may be some points listed in the individual homework assignments. I'm not sure that those track one-to-one with the actual points in the course yet. I have to look at that. I'm not quite sure how it's working. I couldn't really tell until today because the course, it wouldn't let me look at, until the course starts, it's hard to judge what Canvas is doing. I'll just say that, okay? So hopefully I can, if it's not, I'm just trying to tell you, at the end of the day, once the dust settles, there are like 10 homeworks, and I intend each one of them to be worth 20 points for a total of 200 points. That's my goal. So homework is important, right? And any questions about that? How do you do homework? Homework is done electronically, right, through the MyLabs. That also costs money. Sorry about that. But I think it's more than $80, isn't it? Let's see here.
Was it the original book list?
You should have gotten it.
Like what's already listed?
It should be. Let's see if I can let me pretend I'm a student here for a second. See if I can show you. So if I click on like My Labs and Mastering, right? Let me. Can you move the camera over to? It's not very interesting, but thanks. And all right, so if I open My Lab and Mastering, if I try that here, I'm hoping it doesn't let me. No, it knows who I am. Ah, useless. All right, so sorry, I needed to bring my Liberty laptop, which has no login information in it yet, for you to experience the joy of needing to pay for the homework. So usually, if it doesn't know who you are, at this point it'll say, I either need an access code or a credit card number.
Or $110.
It's either $75 or $110.
18 weeks, or you just pay $110 and they could.
110 gives you what?
I don't know. They
You don't know?
say.
I think that's 110 probably the 24 months.
It's like spa service or something. No, what?
So since I had Pearson last semester,
Uh-huh.
does I need to enroll into your course? Like I need a course ID or a link ID?
Yeah, we don't have a course ID link. You'll have to ask Pearson about that. Anyway, I can't fix that. I don't know how to fix that.
You have to get it specific. When you buy the book for the class, I mean, you get this with the sugar.
Well, But if she has if she has all access to Pearson, she should be able to get into the course. Listen, there should be somebody we can ask about that. I don't know how to fix that right offhand.
I know my professor last semester, he gave it to us. It was somewhere on Pearson.
Well, I mean, I can poke around and see if I can find a course code for you, but
He had to do that last semester. So
where it was under,
I have no
you have no clue.
Because all it says is that I need a course ID or an invite link.
So how many people are in her situation? You've already bought access to Pearson and you're supposed, I have 3, 4, 5, all right. Well, I mean, I know what you guys are talking about. In other courses I've had, there's a course code because, but with Canvas, it's supposed to like,
So,
I'll give us about 30 seconds here, then I'm going to pull the plug on this. Unable to load course cards.
Just figure it out.
Oh, they figured out?
Yeah, so if you go through Pearson, because I had access before as well, if you go through Pearson, it's going to ask for a course code, but if you go through the link in the, in the Mac course,
Yeah, so what she's saying is you have to go through the link in the Canvas course. If you already have Pearson access, that should work then.
because you have to buy the actual textbook. This is
I had
whole
the
item.
access code last semester, so I don't have it.
Up to the specific one?
Yeah, it's gonna make you buy it again, I think.
Yeah, I'm sorry if you've had the course before and you end up having to buy it again. It is unfortunate. All right, so let me put away all this stuff unless there's any questions. So I really, again, I don't think there's a course code. Like I've yet to see one for this. But which isn't to say that your professor didn't have a course code in the other thing before. The way things are interfacing here is changing each semester. So like it's different for different courses. Like I have another course where you don't need an access code. It's like automatically rolled into the tuition. So I am also wrestling with this confusion. Okay, so let me put this away. If I can. Well. Okay. So when is the first homework due? Which is this Saturday, right? There are, I think, 50 problems in there, but most of them shouldn't take you too long. All right. So let me just get straight into it with you guys. So today we're talking about factoring. So this is a review. I'm not assuming, I mean, you obviously, if you're here, you have talked about factoring at length in your previous course, right? So there are a few basic patterns that are useful to know about just at the outset before we get into the actual problems. Let me just remind you. Perhaps first and foremost of these is the difference of squares formula. A squared minus b squared is a minus b times a plus b. All right? This is sometimes very useful. Another probably less known thing would be like the difference of cubes. A cubed minus b cubed. This is a plus b times a squared. And there's a minus b squared over here. What goes in the middle? I think, so this is going to give me a plus ba squared. I think it's plus ab. I could be wrong. let's check it, right? So this times this gives me plus a squared b. And that also gives me, ooh, I think maybe it's supposed to be a minus here, isn't it? No? Oh, I'm sorry. This, I think, well, sorry guys. It's been a long summer. A equals to B.
The last one's always going to be positive, by the way.
I think maybe this is is this supposed to be minus here?
No, it's A plus B.
A plus B?
And then the first one's always going to be, or it's going to be the opposite.
This is,
Then the minus AB is going to be the opposite.
that's going to be plus?
Yeah, and then the last one is always positive.
Well, see, that one has to be, if this is plus, that has to be minus, because the only way to get the b cubed here is like from that times that. Well, listen, so whether or not we're right or wrong, we can just multiply this out. We have a cubed plus a squared b minus ab squared plus ba squared plus bab minus b cubed. So what I did right there, so I distribute a times all of this to get these three terms, all right? And b times all of that to get these three terms. Now the question is, am I right? Because I'm going off memory, and my memory is a little fuzzy at the moment here on this. So I don't think I'm right, see, because these two terms should be canceling, right? And they're not. So I think what I have to do here is I have to put a minus in this first one, all right? And I put pluses over here. Okay? Let's try it again. So what I'm trying to do at the moment actually is to factor a cubed minus b cubed. And the ultimate question to judge whether I'm right or wrong, if we multiply the factorization back out, we should get back where we started, right? So am I right or am I wrong? So if we multiply a times that, we get what? We get a cubed, a squared b, plus ab squared, minus ba squared, minus a bab, yeah, minus b cubed. Now is that right? I sure hope so. Do the terms that are not supposed to, is there cancellation of the terms we want to cancel? A squared b and minus ba squared, these guys cancel, right? And the ab squared and this one cancels. Okay, so there, it took a little bit of, scratch work, but this right here is the formula for the difference of cubes, right? So I think I've convinced you it's easy enough to forget it, isn't it? Right? Yeah. I mean, I've done nothing but math my entire adult life, and I forgot it. So you might forget it too. It's been how long since you did algebra? 2 years? 3? Oh. Well, this week may be a bit of an adventure for you then, huh? Now, we also have a sum of cubes formula, a cubed plus b cubed. And that one goes like this. A plus b, a squared minus ab plus b squared, I believe. And you can check by multiplying it out, see it's right, yeah? So like a times a squared is a cubed. Of course, you've got your b times b squared, which gives your b cubed. And then the cross terms cancel, see? Like ba squared is plus, but minus ba squared is minus, right? And then you've got like this plus ab squared, but minus ab squared. So it all works out. So my point in all of this is not that you should have to think through all this. My point to you in all of this is that these are 3 formulas that if I were you, I would put on my handy dandy formula sheet, yeah? Because these will help you solve a lot of problems. Okay? Now, the basic thing before all of this is just the distributive law, right? What's the distributive law? A times B plus C is AB plus AC. Right? This distributive law really is how we guide all of our work, right? Because all factoring is unmultiplying, right? So let's get to some examples here. I need to get a watch. Well, I still have a half hour, right? Class ends at 1, right?
12:15.
Oh, 12:50. Oh, okay. Students never buy into that for some reason. Let's see here. Example 1. Let's see here. How about this? If I have x squared minus 100, can we factor it? Yes. So how does it factor? I look at it this way. This is x squared minus 10 squared. So I'm thinking about a equals to x and b equals to 10 in my difference of squares formula. Yeah, that's the pattern here. Now, you don't have to write that down. I'm just explaining to you my logic. In fact, I would hope you go straight to this. All right. By the way, I should mention, as you're doing homework, it is a very bad habit. In fact, one of the reasons I am, by default, against electronic homework categorically for math classes is it has the tendency of encouraging students to not write their work down. You guys think of it as a game. You just go from problem to problem, finding answers, shoving them in there. You don't have any record of the work that you did. This is a very bad way, right? You need to like write your work down and keep a record of it. Now, I'm not going to assess that really, but I'm just saying it's for your benefit to like try to be organized and keep a record of your work, yeah? Yep.
So in previous math classes, we get credit. I get credit for work, like for answering test questions. We get credit for the work we do as well.
Yeah, there's no partial credit for homework, right? Like homework's right or wrong. But for quizzes and the tests, I do get partial credit, yeah.
Okay.
Unless, of course, it's like multiple choice. But I don't usually give that many multiple choice questions because they seem distasteful to me, yeah. Other questions? Questions are great, by the way. Interrupt me anytime, yeah.
Will the test and quizzes be on paper? Or?
Yes, the test and quizzes in my course are on paper. So I'm teaching sections 1, 2, 3, and 4 of college algebra this semester. And the only thing I'm doing electronically is homework. Now, if you're one of the other sections of college algebra, you probably have quizzes and maybe even, well, I'm not sure about tests, but I know they're doing more electronically in the other sections, all right? But I think it's important for you to have the quiz before the test so that you work things out on paper and discover what it is that you think you know that you don't know. Because 30 points for a quiz, if you completely, do horrible on it, it's not going to be the death of your grade, right? In fact, I usually give some bonus points on quizzes. So if you've got an 80% understanding, you can still make like a 90 or 100 on the quiz, all right? But if, there's definitely a difference between doing problems electronically and doing them on paper, right? And I do like that we can give partial credit. I mean, my wife teaches online, and she does manage to give partial credit to some electronic homeworks, but I have no earthly idea how she does it. But she's wise. So, all right, example 2. Let's try this one. How about 9z squared minus 5? Can you factor that? It takes a little bit more imagination, but if you look at this, this is really 3z squared minus the square root of 5 squared. So if we know about square roots, we can factor this. So depending on what part of your algebra course that you have forgotten about, because it was 2 years ago or whatever, you may or may not have allowed yourself square roots in factoring. But we do, typically by default here. So example 3, if I was going to factor, say, x squared minus 7, I could factor that because I can take this. I can take 7, and I can think of it as the square root of 7 squared, right? So again, I can use the difference of squares formula. All right. All right. Let's see here. So let's look at some other problems. How about x squared minus 3x plus 2? Now this does not fit one of these guys, right? It's something else. So this is just a plain old factoring problem. And the way I do these is I just write x here, I write x here, make myself sort of a blank template, and then I think about how can I get the other numbers? Can I get the other numbers? How to get 2? 2 is what, 1 times 2, right? Or minus 1 times minus 2. And I need to get that 3, but I need to be minus, right? So like here's what wouldn't work. If I tried plus 1 and plus 2 here, that wouldn't work because I get a plus x and a plus 2x, right? That doesn't work because I need a minus 3 over here, right? So you think about it, you go, oh, wait a minute, no. I need to put minus here and here. So this thought process I'm just outlining for you is called, guess and check, right? So if at first you don't succeed, try again, right? So there's that one. Example 5. What if we had x squared plus 4x plus 5? Can you factor this? So we put an x here, we put an x here. What do you think? We try 4 and 1. So if I do 4 and a 1 here, right? What happens? This multiplies out to x squared plus x plus 4x plus 4, right? Oh man.
If it's a negative 5, you can.
But see, if it's a negative 5, you can. See, that is a freedom that only I enjoy. See, once you get a doctorate in math, you're allowed to change the starts of questions in your course. It's one of the rights and privileges that is accrued to you with your PhD. It's true. But unfortunately, students are not allowed to change the problem. I mean, they're exactly right. If I had minus 5 here, then, well, to quote my community college professor, that dog will hunt. Let's see here, x minus 1. Absolutely, because then we get plus 5x, minus x, we get a plus 4x, we get a minus 5. We're all, how do they say, aces? I mean, fine, that one works. Let's call that example 6. But example 5, what's going on there? That didn't work. Can we factor this? So apparently there are some quadratics which cannot be factored using real numbers, right? How do you know if you're facing such a problem? You Google it, you look at Chegg, Course Hero, no, these are wrong answers, right? Doing the homework is not finding answers to the homework, it's understanding the homework, working it out for yourself, right? So let me remind you a theorem. So here's a handy dandy theorem which we will prove another day. I don't prove many things in here, but here's one I will. If we have ax squared plus bx plus c is prime polynomial when b squared minus 4ac is less than 0. And prime, or sometimes other people will call it irreducible, which is harder to spell, but unless you abbreviate. Haha, no, I find irreducible, some people call it irreducible. That means it cannot be factored over the reals, right? So in example 5, what do I have for my coefficients? I've got x squared plus 4x plus 5, right? This gives me a equals to 1, b equals to 4, c equals to 5, right? So if I look at b squared minus 4ac, what do I get? I get 16 minus 4 times 1 times 5. 16 minus 20 is equal to what? Negative 4, right? That's less than 0. Game over. This does not factor. So it doesn't matter how long we tilt our head and squint and try different combinations of like factors of 5 and 1, we're never going to be able to factor it over the real numbers. I think it's good to know this because whenever you run across a problem in your homework where it's a prime polynomial, if you didn't know this, it would always be a little bit unsettling. Am I just missing how to factor it right? Well, no, we're not missing it. Can't be factored without complex numbers. Do you guys remember what this is called? Anybody know? It discriminates what kind of solution you have to the quadratic equation. This is called the discriminant. All right. More on that later. Let's see here. So example 7. Suppose we had x squared plus 4x plus 4. Can we factor this? Yeah.
What would you want us to write on a test, like if you gave us a problem like that?
Oh. So the instructions would likely be something like factor these polynomials completely over the real numbers, all right? And in this context, you would say it's already completely factored. I mean, so basically you just, if that was the starting point, the ending point would just be to write it down again. And I think in your homework, it's got like some like multiple choice, like either you put in the factorization or you marked the button which says prime. So I just wanted to give you guys a tool so you know, because it's, you know, how many of you remember this from your previous algebra course? Some do, great, good, good. Did your teacher have some sort of like limerick to remember it with? Some sort of musical rhyme or something? No. I will give you none of those, so my apologies. But I was looking for some. Oh, no, I wasn't. Oh, yes, I was. I was looking for problems. See, these kind of problems I can come up with, but there's other ones that are trickier. So, okay, so this one, can you guys tell me? Can that be factored? What do you think? Oh, did you move over here? Yeah. Is what? I heard a +2 and a +2, is that right? So this is actually the case of like a repeated factor, right? We could write it this way. I would count either of those as right on a quiz, yeah. Let's see, here's another one. So this is one from your homework. It's a little bit different. 7x to the 5th plus 14 minus ax to the 5th minus 2a. And we're told this one we're supposed to do factoring by grouping. Let's see here. So when I look at this, the two things that kind of jump out at me are there's a 7 common to both of the first two terms, right? And there's an a common to the last two terms. So from the first two, I will factor a 7 out, and that will give me x to the 5th plus 2, thank you. And then for the other two, I have an a, so, and I think I can factor the minus a out, actually. I'll just say minus a, and then I've got an x to the 5th Oh, plus 2, because minus a minus is a plus, right? Excuse me, I'm an idiot. I mean, minus times plus is minus, right? So what I'm doing here is I'm using the distributive property, right? So this technique is known as factoring by grouping. Now what can I do?
You take the 7 and the negative.
Yeah? Take the 7 and the negative a, and yeah, this is the same as 7 minus a times x to the 5th plus 2. And there you go. Now, technically speaking, this is not completely factored over the reals. It is true, but hideous, that this can be further reduced. But that is unfriendly in a college algebra class. So I try to, if I ask you a question like this, I won't say factor completely, I'll just say factor, which means that you make a non-trivial step and then you get to a point where you're like, all right, yeah, past that, that's for math majors. Yeah. So another one. What if we were facing, let's say, x cubed plus 125? So what's 125? Yeah. Yeah, 5 cubed, right? So this is x cubed plus 5 cubed. So now we go back and we use our sum of cubes formula, right? So it should be x plus 5, yeah? Times what? Times x squared. Is it minus 5x? Plus, I'm supposed to do x squared minus a times b, which here a is x and b is 5, yeah? So minus 5x plus 5 squared. What's 5 squared? 5 squared is 25. And that's as far as you can go. Fun fact, any of these ones, when you do this kind of factoring, it will always be the case that the quadratic that appears over here is a prime, so you can't cut it down further. So I can tell from the, oh, we still have 3 minutes. Somebody's letting their class out early. Someone's being cheated out of valuable minutes of education. You guys pay good money for that. Someone just cheated them. Sad, sad, sad. Let's see here. One more. We'll be done for today. How about this one? This one's a little bit weirder. We haven't had one quite like this yet. Example 10. 6r squared minus 23r plus 10. So this one's more annoying, right? Because the leading coefficient with the squared term is not just 1, right? My examples for the most part up to now have been nice. They've just had an x squared, right? 6r squared. How can we could parse that a lot of different ways. We could do r times 6r, right? But probably it's going to be something like 2r and 3r here if I had to guess. All right? How do I get a 10? Yeah, I get 1 times 10 or 2 times 5, right? Or minus 2 times minus 5, etc. What do you think we're going to need here? I feel like the 2 and the 5, right? And we need a negative in the middle, so I think they're both going to be negative. I'm going to try minus 2 and minus 5. Did that work? I don't think that worked, right? Because that gives me minus 10 and minus 6, which when I multiply it back out, I don't get a minus 23, I get a minus 16, right? So that didn't work. What if I flip these? What if I put the 5 here and I put the 2 over here? Does that work? Then I get minus 15. And what's 2 times 2? Minus 4, I get minus 19. No! Oh, no. Well, what do you think then? So is this doesn't seem to be working. Maybe we should try something else, right? Maybe it is the 6R and R. What do you guys think? If we do no, I think no. Let me not. Sometimes you gotta. I've lost my eraser shirt. Oh, it's all the way over there. I should have stuck with the other one. I just haven't exhausted the possibilities. What should I have tried? Negative 10, negative 1. You guys saw it. You're like, when you see me going down this path, you should be like, no, don't do it. All right, so we almost. So I do what? You guys found it. Negative what? And 1? The other way?
Yeah.
So like this?
Yes.
There we go. So if you need to see a few more examples of factoring next time, we can do that. But after that, we're moving into manipulating rational expressions. So thanks, guys. Nice to meet you all. Hope you're enjoying your first day of classes. Here, I'll stop this thing here.